Today we are going to do the next question in the list of binary search questions, and this question is Koko eating bananas. So this question is asking us about Koko eats bananas. There are n piles of bananas, and the ith pile has piles ith bananas. So there's a list or array indexed by I. The guards have gone and become back in each hours. Koko can decide her bananas per hour eating speed of k. Each hour she chooses some pile of bananas and eats k bananas from that pile. If bananas per hour, right? If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Okay? Let's eat slowly, but wants to finish eating all the bananas before the guards return. Return the minimum integer k such that she can eat all the bananas within each hours. Okay, a little bit confusing, but let's just take a look at examples. So we have piles, h equals to 8, right? And the output is 4. So these are the piles. There are 4 piles of bananas, right? And then n equals to 4, and h is 8, right? So we're looking at this h is 8, and the output equals k equals 4, minimum integer k. Per hour is the minimum she can eat. Speed in order to eat all bananas within 8 hours, right? So how does this work? If you have 4 hours, you come here and then you have 4 per hour, right? So you come here, you would just need, if this pile has less than k bananas, each of them will not eat any more during this hour. Okay, so I assume that this is 3, 6, 5, 7. So she will eat 1 hour here, 2 hours here, another 2 hours here, and 3 hours here. So 1, 2, 2, 3. This is 5, this is 8, so it's within 8 hours. Yeah, essentially because she eats k bananas per hour, she'll spend 1 hour here, she'll spend 2 hours here, 2 hours here, and 3 hours here, altogether spending 8 hours immediately. So basically maximizing the number of hours she's able to fit within 8 hours. So ideally it wants to be 8 hours, right? So this is, yeah. And then when we are looking at the next example, right, h equals to 5. So if you want to eat 5 bananas in total, you have only 5 hours, right? So perhaps this will be hours, right? Then we have this. So in 30, we will probably, here the answer is 30, right? So 30 per hour, you need to eat 30 per hour here, and then you spend 1 hour here, 1 hour here, 1 hour here, 1 hour here, 1 hour here. Altogether you have 5 hours because you have 30 bananas here, right? He wants to finish all bananas. She can eat all bananas, right? And then here again we have another pile, and here we want to take a look at the hours, right? And here we have 6 hours and 5 piles. However, we probably need to finish this within an hour 1, another hour 2, another hour 3, another hour 4, another hour 5. 5 to finish, but the answer here is 5. So here k is 30, right? If k is 30, right, then she will spend 5 hours, but she is given 6, right? So what can we do? We can drop it to 23. 23 will be here. If k equals 23, then she will spend 6 hours, right? So it's like that, right? So we're looking at this. Pulse length is in between this and this. Nothing much to really take note. I guess the main question here is, how do we know what k is, right? So obviously in this case we can do a brute force solution, right? To pulse I is less than h, right? We have pulse I that is less than h. So this is a very important constraint here. We are given that this is this, right? So pulse dot length is smaller than or equals to h. So it's important because for the number of hours that we have, for example, if you're given 6 hours, then there can be a maximum of only 6, right? Yeah. So this is very important because otherwise, if we can have a larger number of pulse than number of hours, then there might be a situation where it's impossible to find the answer. Right? So it's going to be impossible to find the answer if pulse dot length is smaller than or equals is larger than or equals to h. So anyway, yeah, I don't think I need to explain that in the interest of time. For solution would be, we would just simply set the pulse length and hours, set the per hour, set k to be the largest bundle, right? Largest bundle size, pulse size. Decrement it along, right? Slowly by 1, slowly until we find that we cannot ingest all pulse within h, right? If you another one, so this is like what a solution is to sort the array, right, in descending order. Decrement your pal k by pulse sorted I until we can't find, right? So this solution obviously is not the best. We'll use this, right? And we find that we cannot ingest the pulse within each. So for example, in this case, we will start with 30, then we will start with 23, and then we start with 20. So here we have 20, right? Let's try this, right? And then we have this, we have 23, 20, 11, and 4, right? 1 2 3 4 5, right? You sort it. Then you start with k equals to 30. You do this, boom 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 boom, and then you realize that, hey, but in this case we have to see whether or not 23 is going to be the next value. What if this was 29 instead? What if this was 20 instead, right? What would we do, right? If this was 20, I would use 20, 2, 2, 1, 1, 1, 1. So the answer is still the same, right? 2, 1, 1, 1. But if this is 30 and this is 40, I would probably have to use 30, 2, 1, 1, 1, 1. Still the same, right? This is 40, it's 30. Yeah, you want to be as small as possible. You want k to be as small as possible. Alright. So you would take the second largest one, right? You would start from, so you start from from 0, right? You start from 0. Now the question is, should I sort it in descending order or ascending order? Let's say I sort it in ascending order, and then let's say we do this, and then we increment our eating speed. Increment it one by one. We increment this speed here in descending order or ascending order. We want to increment it in ascending order. I think the solution here in this case would probably be since we want k to be as possible, to be as small as possible, it makes more sense to sort in ascending order and find the appropriate speed, right? So when we have the piles of here to be 4, 11, 20 and 30, we want to find that if k equals to 6, k can be h can be either 5 or 6. So let's say we have this, right? We're looking at this, and if h equals to 20, can h be 20? Yes, definitely. So if h is 20, what do we want to do here? We have 5 pounds, right? And we have 5 pounds. We have 5 pounds, and h is 20. Ideal case is for us to have to spend only 4. Ideally, we want to spend an average of 4 hours per pound to enjoy, right? So let's see if 4 can work. So your speed is equals to 40 divided by 10, right? Equals 10 equals k. Then let's see if 10 works, right? So you will have essentially 1 hour here. Your k is 10, right? So you have 2 hours here, 2 hours here, 3 hours here, 4 hours here. Five 17. You eat within 17 hours. Can you slow down to make k equals to 3? Let's try. If k equals to 9, it would probably be 1, 1, 1. 3 hours. 3, 4, and 5. And then equals 2, 5, 6, 10, 15 hours. No. This doesn't work. Right? When we look at this power sorted ascending, we cannot, no, this idea of dividing the average, dividing the average is not useful, right? Dividing the average is not deriving. In fact, we should just go back to this particular question and see if we can go 4, right? So we first check whether or not 4 is possible. If we spend an average of 4 hours per pound, right? We will probably spend 1, 3, 5, 8, 10. So we add this all up. It's greater than 20, right? So no, you have to move on to the next one. 11. 11 will be 1, 1, 2, 3, 4. You add this all up. 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 4 is 11. Minimum K. Four plus 5, 9, 9 plus 8, 17, 27. If you eat 11, it's too much. It's too much. If you eat 11, it's too much. Yeah, if you eat 11 here, it's too much. 1, 3, 5, 8, 10. If you eat 27 hours spent. Too long, right? Nope, we cannot use the bundle size directly. But how about if we use speed? Yeah, 4 actually makes sense, because the average we have 4, right? We want to round it up and then we take 5. Let's say we try 5, right? Speed equals to 5 is essentially 1, like that, right? You spend 1, 2, 4, 6, 8 equals to 6, 10, 10 plus 14, 24 hours, right? Then you want to increase again. Speed equals to 6, 1, 2, 4, 5, 7 equals to 1, 2, 3, 4, 5, 6, 7, 6, 3, 7, 12, 19. Yeah. So essentially what I did here was I found the average time that I need to spend per pound, right? The average eating speed that is needed for per pound to enjoy, right? 4 hours per pound, you have 40 divided by if h equals to 20, we have 5 pounds. We have 5 pounds. We want to spend an average of many things per pound. You want to spend 4 hours per pound. This average is also right? This makes sense, right? Because of this condition here. Pulse dot length smaller than equals to h. So if equals h, then speed equals to 1. Right, so we got this condition away, right? And then here we have pulse sorted ascending 4, 11, 20, 30, 40. If h equals to 20, we have 5 pulse. We're going to spend an average of 20 divided by 5 equals to 4 hours per pulse, right? Yeah, I guess I'm kind of stuck in this question once again. If I have a bigger pile, if I have negative 5, I essentially will start from the average and then I'll work out, right? If I were to solve this solution, if I were to solve this solution, I'll probably start with the average and I will increment the hours gradually, brute forcing, to increment it. How can I use this sorted pile to my advantage? That's the question. If I have something that is sorted, right? Since I know that this is a binary sort question, am I supposed to actually find a binary sort this entire array, and once this array is sorted, I will actually find the number between these two numbers. So the average would be 4, right? So I want to find a number in here that is between 4. And then I will check between 4 and 11, the middle between 4 and 11, check if I'm smaller than equals to the eating speed. Okay, let's try this. So if I have pause something ascending, right? And essentially I would do something like this. I have pause sorted ascending. I would check for a speed between 4 and 11. The middle of 4 and 11 would probably be around 8 or 7. 7 minus 3 is 4, 7 plus 3 is 11, 7.5, so 8. Right, you have 5, 6, 7, and then you have 9, 10, 11. So 8 around there. Right, 7 or 8. Let's round it up to 8. And then since 8 is too fast, I would sort and then find the answer. yeah, essentially this is how I would kind of solve the question. Unfortunately, I couldn't do it within 30 minutes, but the general idea is to sort the piles into ascending order, and then using these values I will actually find a target. So initially I would split this using binary search to get 20, and I will discover that 20 is in fact too quick of a speed for me to eat, and since the target I want to find is smaller than 20, I would find something here. And since I have something here, I'll probably end up at 11, and 11 is still too big for me. I know here my answer is about 6, right? So 11 is still too big. I would search between 4 and 11. Between 4 and 11, binary search. And yeah, unfortunately this is a pretty difficult question. I will review the solution and get back. And yeah, that's all for this video.